In here we do have the basic setup I already provided in the scene. So the floor and the block are fine. We want to change the man and the woman mesh, because right now they are using the static one directly from the FBX file. So here just replace the source with the FX outman source, and this is the one with the mask, so it should be here, and it is. And just take a point wrangle, and we want to iterate here only when the at mask is equal to 1. We want to remove the point, so remove point 0, the current point number. So basically this is our animation on this mesh. Let's copy this wrangle, and on the woman container let's paste it, and we need to replace the source woman inside FX, and we do have our correct setup. So it should be already working, and it is. And I finally fixed my Karma XPU issue, so we will use XPU this time. Yeah, okay, never show again. So drop down a Karma setup, and I want to switch it to XPU. Let's set it to 32 for now. And let's see what we have. So we do have something like this, and this is actually now this is up to you to make a call, because basically we are seeing the backside of the polygon when we are deleting the the one that are facing us. So I left it as it is for my final render, but if you want to cull the back faces of a polygon, you just need to take geometry, where it is, render geometry setting, append it like for the man, and on geometry you can set or create the cool back faces to on. So this is merely an artistic choice, it's up to you. I will leave it as it is for now. And I want to do a slight modification on the material. I want to use the edge map to drive a little bit of darker value around the edge. So if I go in the material of the man, here we have the base color, which currently is being multiplied with some ambient occlusion texture already. We also want to multiply it for the edge map we have, and we can retrieve it with the geometry property value. It was called edge, and it's a float value. And let's see, plug it to the base color, let's see what happens. Reset Karma. Where is everything? Put it into the default. Shouldn't be here. Here we need to plug edge. So base color, and we should see something. And let's go back here, or we can't see the materials. So many. Yeah, we are multiplying the edge color. So invert it, and this will be multiplied by the current base color. So something like this. And maybe, I mean, yeah, the full amount is fine, whatever. And we want to do the same for the woman, so copy these two nodes, go inside the other material, make some room, paste it here, take a MTLX multiply, and multiply it over here. So we have the two animated mesh. Now before bringing in the petal, let's go back inside the popnet. We do have all this amount of points, like at the peak they are 120k, something like that. We don't want to use all of this point for the petals. We want to use, let's say, half of it for the petals and half of it for just like something that resembles a simple dust, just to add something to the overall effect. So let's take a group expression over here, and in here we will create a new group for the points. We will call this dust, And basically we can take all the even ID. So let's say at ID modulus then 2, and we should have a group with half of the points. So now we can split the dust group, and basically here we do have the points for the petals. So out pop petals, pop, and this will be out pop dust. Now for the petal, let's just for now take an object merge here and go and pick the petal geometry. Let's try to instance this with a copy to points, just for visualization purposes. Let me use the dark background again. Basically we want to tweak the p-scale a little bit, so let's take a point wrangle just right after the cache. And the p-scale we are using right now is fine because it's driving the mass, but we want to randomize even a little bit more and also animated, so in the beginning of the birth of the particle they will be actually smaller, a little bit smaller. So inside here let's call it p-scale, final p-scale, and let's set it, first retrieve the new age, which we need to recalculate because we kept the age and the life but not the normalized age. So float new age is equal to f at age divided f at life. And now the f at p-scale, it will be equal to the fit 01. We want to fit the ramp as usual, so p-scale ramp over the new age we just calculated. And let's create two channels for the minimum p-scale, so min p-scale and max p-scale. Let's click here. So let's set it, let's visualize the instance of the grid, the petals, and also set some minimum value here so we can see something. Let's set the maximum to 1.4 and the minimum to 0.3, let's say. And this will be over the life, so right now it's linear. We do know that we have 10 seconds on all this ramp, so we can do something like this. So in the beginning they will be small, and I believe something's wrong with the scale. How big is this guy? This is one. Oh, right, we don't want to set the p-scale. We still want to use the one that we set with the mass, but we want to multiply the previous p-scale for this other value. So we end up with something like this. And on the other side, we do have the points for the dust. So 50k here and 50k here. Now, if we drop down a quick material on the petals with the correct texture, here we should still see the whole contact sheet. So as you can see, we see all 8 of the variant, all the 16 of the variant here on each petal. We will basically use an attribute on the material to offset the UV, but we can actually do it here and then use the same code on the material. So here we can have an immediate feedback on it. So after the copy to points, let's put another point wrangle. And in order for this to work, at least this visualization, we need to promote the UV to a point parameter. So take an attribute promote after the petal geo. We want to promote from vertex to point the UV attribute. So now we do have the UV here as a point attribute. So the idea here is, let me split the view so I can target also the UV view over here. Basically, let's take UV transform here. You can see that right now we are taking the full UV grid with this guy. So let's scale it for a second to be a quarter of it, so 0.25, 0.25. What we want to do is, if we take another one, is reset the scale. Basically, for each one of the petal, we want to randomly move it on the coordinate of one of the variants. And since this space is going from 0 to 1, basically to choose the position, the point will need to have some value associated, which will be 0, 0.25, 0.5, or 0.75. This is the sense of this whole thing. And basically on the point wrangle here, let me pack an instance for a second so it will be lighter. Basically what we want to do is first we need the number of the tiles. We have 16 tiles, so int tiles is equal to 16. Then we need something that will drive the seed, and since we kept the id, we can use that. So int seed is equal to @id, and then we need to create basically this integer variable in a random way. So each petals will have this value from 1 to 16, or rather 0 to 15, to choose the variant for the texture. So let's create an integer variable. We will call this variant. And we want to use the random function over the seed, so the id, plus maybe some other random seed, so chi seed. And right now it's going from 0 to 1, we need it from 0 to 16, so by 16. And of course you can have all of this procedural with a channel and tying everything together, but we will be quicker this time. All of this we want to convert it to an integer because we want an integer value. Alright, we need the parentheses here and at the end just 1. So now we have from 0 to 15. Now to use this number to actually offset our UV, and let me just delete everything but a bunch of points so it will be easier to see, something like this. So I can disable the packed instance, otherwise I won't see my UV over there. Right now we are seeing just one petal because with this UV transform we are simulating just one cell. And also let me change this value from 16 to a channel because the tiles are actually 4. The total of the tiles is 16. So click here, the tiles will be 4. And here let's just do parentheses tiles by tiles. And another parenthesis at the end. So it will be the same, but it will be correct for the following calculation. And we can delete this attribute, we don't need it. So basically we can't use a number from 0 to 15 to calculate the offset because we have a grid system. So when we reach the maximum number of columns, we need to go back and change the row instead. So basically we need two values, integer, a column and a row number. So int col, it will be equal for the time being. Let's just create an integer channel, so chi col, and also another one for the row, so int row chi row. Then we need an overall size, so size will be equal to 1 divided the number of tiles. And then we need to compute the vector UV attribute, so vector2 offset, we will call this offset. We want to set it to the number of column by the sides and the number of row by the sides. And in the end we will bind it to an attribute, but for now just add it to the current UV. So u@UV plus or equal offset. And if we create this pair parameter and increase the value, you can see that we have the offset. So as I was saying, we can't exceed the number of tiles. We need to increase the column once we reach the maximum available tiles. To do this, basically we want to do the modulus of the column for the number of tiles, and the row will be divided by the number of tiles. So now, as you can see, when it reaches the maximum value, it comes back to the first one. Same for the column. And of course, we don't want to use this integer channel. This was just for demonstration. We want to use the variant. So variant, and variant. So now, as you can see, we have differentiated all the petals. They are taking basically the full UV, but now it's not just one grid, they are all the instances. And in here we can delete these two parameters. So row and column go away. And basically this is it. Now we just need to do this same thing in the stage. And here we just want to copy the point angle. We can leave everything as it is because basically for the points we are taking this in the stage, and for the petal we are taking this thing. All of this is just for visualization in the SOP context. So go back on the stage, and here we want to take a instancer. So after the merge, or rather the merge will be the input stage, and we want to take a SOP create to take the petal. So petal, and inside let's take an object merge, and it was petal out petal geo. And in here we don't have to do anything, we just need to plug it to the right side of the instancer. And right now it's complaining not display not found because we don't have any source for instancing. So let's rename this one to petal instancer. And inside we want to take the points from the pop simulation. So it was pop out pop petals, these guys. And now we already have the instancing, but we need to make that thing on the offset. So paste the point angle, and inside here, instead of adding to the current UV, let's just create a new attribute. We will call this UV offset. And it won't be plus or equal, it will be just equal. And also we need to compute some velocity because we want to use motion blur for this shot, and we didn't keep the velocity from the simulation. So here basically we want to calculate the speed matched by attribute id, so it will use the same particle. And we are good to go. Maybe just create a null, let's call it out PTS. Now if we go outside, we need to create a material for the petals, so make some room here, connect the instancer, and maybe for the time being let's disable all the light. We want to just use the dome light. I will set the intensity maybe to 2, so it will be faster to see what's happening. Now in the material library let's create another Karma material builder. This will be for the petals, and inside let's take an MTLX image. This will be the base color, so this one, and we want to plug it in the base color, and let's duplicate it for the opacity, and this is a float value, and this will go into geometry opacity. Not sure if we can see it from the Houdini VK. Let's see, go outside, we need to link it still. So autofill material, and here we want to assign the petals to the petal instancer. So let's see if it did work. Yeah, the material is here. Now we need to apply the offset to the thing. And the reason for this attribute not doing anything right now is because it's on the point, and the UV are on the vertex. We transferred for the display purpose, but now they're on the vertex, and so we need to go inside the material and use this text coordinate. Basically we want to replicate that workflow that we did to offset UV on this text coordinate. So if you remember, the first thing was that UV transform to scale the petals by a fourth. So basically we want to take the texture coordinate of the object, which you can take it with this node, which is the MTLX coordinate, and we want to basically multiply it by 0.25, so we get the correct scale. So this will be in the first input by 0.25 and 0.25, and if we plug this into the text cord, you can already see that now we are seeing only one petal. And basically this is the death battle which is in the bottom left corner. Now, to take the offset, we want to take another geometry property value, and we can retrieve it like this, offset, and it was a vector 2. And now we just want to add, after this multiply, this offset value. So this will be the first one, the result of the multiply will be the second, and this will go in the text coordinate. And I don't think we can see it in the Houdini viewport, but if we go outside and try to make a render, we should see all different petals. And we don't. Why we don't? And why I do see all this outline? Because we didn't call offset, we called UV offset. Yeah, now it's working. And finally, for the petals, I want to set the specular, or rather the roughness to, let's say, 0.6. And let me restart the render. And also I want to take a color correct, so MTLX color correct, and for now let's just visualize it on the base color. I want to increase the saturation, let's say 1.4, and also some lift value, so I can use this map to drive some surface scattering. And we want to plug it basically on the color. Let's take the original base color map. We won't see much right now because we only have the dome light. And on the subsurface parameter, let's increase the value to, let's say, 0.1. And we want some warm color for the radius. Let's say something like this. And also we need to enable, where is it, the option, the thin walled option. This will be very effective when you are dealing with very thin surfaces. And that's it for the petal material. While we are in the material network, let's just create another one for the dust. So let's call it dust. And for this, let's just decrease the specular to 0 and set some dark gray value, like this. So outside, basically we don't need another instancer for the dust, we just want to render it as point. So we can take another sub create, this will be the dust, and we want to merge it, let's say after the instancer, right here. So inside, let's take an object merge, and we want to take the out pop dust, so this guy. So autofill to get the new material, and for the dust, let's take the dust. And let's restart the render, we should already see all the... And of course we didn't change the p-scale, so let's go back into the petal instancer, let's take the point velocity, because we also need that. And inside here, for the dust, let's paste the velocity, and let's take a point wrangle, we just hard code some p-scale value, so f at p-scale is equal to, let's say, 0.01. So if we go outside, we should fix, yeah, the p-scale. Let's see from the camera what we have. And I'm quite happy. So we're almost set for the final render. Let's delete this dome light and replug all the lighting setup. And for the camera, I just set an animation, some parameter on the focal length, and I also changed the shutter from 0 to 0.5, because by default you will get this value, and this will give you basically some motion blur behind the object. I don't like that very much, so I prefer 0 to 0.5. And now we just need to set up the Karma render and also the IOV, because we want to do a little bit of compositing inside Copernicus. Now, for the Karma parameter, first thing first, let's go on the camera effect. We want to disable the depth of field. We will apply some with the Z-Pass. And for the motion blur, we want to change the velocity blur to velocity blur. Otherwise, we won't get any velocity from the particle. Same for the instance velocity blur. Set it to velocity blur. Then on the image output, we want to set some AOV. Let's see what we want. We want the combined diffuse, and for the reflection, let's take the combined glossy one. We also want this subsurface scatter pass, and then we need some utility pass for the denoise and for the z-pass. So go on the utility, and we want to output the motion vector. This will be used by the denoise, the depth for the z-pass, and where is the albedo? We want to use also the albedo. So if we take a render, we can examine those single passes. Let's disable this thing and go to the dark background. So with this button you can see the single passes. So as you can see, we have the diffuse component, the reflection, then we have the subsurface scattering pass, and the depth, even if it seems wrong, is actually correct. It's just that we have a range that is going beyond 1 and we can't really see it as an image. 1 is white. So then we have the motion vector, and on this pass basically the black represents the static stuff and the green and red the moving stuff, depending of if they are moving in the horizontal way or in the vertical way. And what else we have? The albedo, which is basically the color without light information. This is also used by the noise. And that's it, we don't have any more passes. So for the setting, let's see, I want to set this path trace sample to 128. Here I want to output a full HD, so 1920, and the height will be computed by default. We don't want any denoise, we will apply the denoise in the compositing area. And for the output, we want to write it to the job variable render and if name. We don't want to append this stuff, so let's say just render Gommage and $f4.exr. We need to export it in EXR. And I believe we are ready to hit the render button. Keep in mind, on my setup it took something like 7 to 8 hours to render the whole sequence, so maybe render it overnight. And just let me check if the motion blur is actually working. So I will make a quick render and save it in the snapshot strip. Let's disable the motion blur and let's see if there's any difference. So save this other snapshot and let's see. Yeah, it was working. So let's stop the render and hit the render button. So I have my sequence rendered out and it's quite heavy. XR can do that. Now we want to composite with Copernicus. So let's go back to the OBJ level and drop down another comp network. We will call this comp and dive inside. In here, just take a file node and we want to retrieve the EXR sequence. So render, Gommage, all the sequence. And we don't want to see it from here. Let's watch it from the composite view. So you can see as an actual image. And click on add AOV from file. This will create automatically the output for the AOV. So super simple setup here. Let's take a blend and let's start to take the AOV. So take a null. This will be the base color. And we want to blend it right away. Sorry, not the DC, because this is the beauty pass. We need to take the combined diffuse and blend it with the other pass. So take the glossy reflection for now. So 1 and 2. So we want to blend the base color as a background with this foreground in HUD mode. So we do have something like this. As you can see, only diffuse. We're introducing the reflection. And we want to brighten this thing a little bit. So take a bright node after the reflection. This is reflection. And and maybe increase it a little bit, so let's say 1.2. There's no need to shift, let's leave it as it is, and duplicate the null. We want to take the subsurface pass, take another blend, and we want to add this together, so like this. Now we want to use the reflection pass, this one, to generate a little bit of glow. So take a glow node, source from the reflection, and here let's go back in the timeline when we actually can see some reflection on the characters, so like at the start. And for the glow, let's lower the threshold by a lot, let's say 0.04. We want to output only the glow, not also the mesh. And let's lower the brightness. And we want to... maybe this is fine, just on the brighter parts. Let's try to blend it with another add, so background, foreground. And we do have something like this. This is maybe way too much, so let's lower the size to something like 0.02. Then we want to apply some denoise, because right now it's pretty noisy. So let's take the noise I node. Doesn't use AI, I guess. It's just to set the optic denoiser. We want to use that one. And as you can see, we have the source and also ask for normal, albedo, motion vector, and preframe. We do have motion vector and albedo. Those will be enough. So let's duplicate this null, and this is SSS. This will be albedo. And this will be motion vector, so let's call it MV, and take the albedo for this one and the motion vector for this other one. So this will go here, albedo, and motion vector, it will go here, here. So now we do have the correct denoise applied also at temporal level, and it will be very clean. So now we want to apply some background, so let's create another file node. You can find this image in the project I provided, so it's in the text folder, and it's not in the text folder, it's in the image folder, the BG plate. So this one. Now we need to blend those two together, but we don't have an alpha channel on the main output, so if we set it as a foreground and the other as a background, we can't really blend those two together. We need to extract with a channel extract the alpha channel, and we want to take it from the beauty pass, so reroute it from here, and as you can see here we have red, green, blue, and alpha. We want to convert the RGB, where is it, to RGBA, so the denoise will be the RGB value, and we can append the alpha channel. So now if we blend it, we do have some correct behavior, and we need to set the mode to over. And also let's take a blur, let's blur this alpha channel by a tiny bit, so let's say 0.002, and finally we want to apply some depth of field. So before appending the alpha channel, let's make some room over here. This is the noise. Let's move these guys down here. Let's take a bokeh node. So we want to plug the source of the denoise, and we want to set the radius to, let's say, 4 or maybe 4.5. And now we need to use the z-pass, which is we didn't create the null, no, so let's duplicate this one. This will be the depth, and let's take the depth. So let's move this guy. We want to feed this into a remap. So basically now if we see it, now this is going from 0 to the farthest value on the scene. And I know that my basically focus needs to be from 48 and 55. And now as you can see, by remapping the value, you can even see correctly. We want to feed this into the radio scale. So now we are basically blurring only the farthest value, and we can actually do it after the alpha appending. So let's change the order. So the RGBA will be the source of the bokeh, and the blending with the background will be the final operation. So we do have something like this. Finally, let's take a null. This will be out cc render, and we just want to write it. So a raw image output that will reference to the scope path. Here, let's just save it to job render cc, and let's call it gommage.$f4.png. And remember, we want to embed the color profile into the image. So here we want to set bake to open color IO display view, and the view should be ACES 1.0 or whatever color profile you are using from OCIO. And if we hit render for the current frame, let's just check it with one frame. Let's go on the render folder, cc. We do have the correct output. And this basically concludes this tutorial. So once you render out the whole sequence, you will end up with something like this. I really hope you found this video useful. I really wanted to make something about Expedition since I finished the game. I really enjoyed that product. And as usual, if you enjoyed the video, drop a like, subscribe to the channel, and I will see you in the next one. Cheers!